Welcome back to another video on Common Motion 2D, training a VAE-LSTM model. So in this video, I wanted to cover setting up the data loader as well as the training loop. In the last video, we talked about preparing the data set itself, which is basically separated into samples like this. So preparing the data loader with Burn is actually pretty simple. We start with defining each row in the data set, and we name each column. We also set up the whole data set, like so. And we use some of Burn's built-in structs to implement these features. And these are just standard ways of doing this. And this number of features corresponds to the number of columns. And that's how we refer to those. There are features that the model derives from the data, which is sort of a different way of using the word. We also have these features which are sort of hard-coded into the data. So, as we go on, since we're extracting from a text file, we put together a from string function, and it does some pretty obvious logic here, splitting the samples, splitting the prompt from the completion, and then basically collecting all of that data into these keyframe items. So it's pretty simple. You can debug what it looks like if needed. As we move forward, we need to set up our batcher. And this essentially enables the ability to load multiple samples at once into the model. And this can have all sorts of different effects on the types of outputs that you get at the end when you're inferring from your model. It can also have big impacts on the training as well. So, as you'll see, we only use a batch size 1 for this model because, well, essentially, having too much generalization can harm the quality of certain models. So if it learns patterns between samples, it can sometimes not learn each sample to the fullest. So it just depends on your task and your use case. But nonetheless, we put together the batcher, standard burn practice. So the inputs and the targets correspond to the prompt and the completion. One important component of loading in these samples or sequences is they all have to essentially be the same length in that batch. So it's important to pad the sequence. And we literally just insert zeros wherever there is data that doesn't match the maximum length for that batch. So that helps the model essentially ignore that portion of the data and focus on the patterns that really matter. This is how we bring it together. We grab the max lengths, we pad the sequences, and there we have it. We have our keyframe batch. It's also important that we put together our normalizer. I talked about this briefly in the last video when we extracted the normal values from the data set, which basically just gets us the mean and the standard deviation. This enables us to basically take all of our values, which can range, low numbers, big numbers, all sorts of numbers, and basically put them into a value between 0 and 1. So when all of them are between 0 and 1, the AI just has a much easier time learning and adjusting to these values. So of course, with some values, 0.01 is going to make a bigger difference, and with others, a less of a difference. But that's just standard practice and the best way to do it. So it's pretty simple. We have a normalize and denormalize function here. So that way we can set it up for insertion into the model, as well as denormalize when we are taking it out. So that's about it for preparing the data loader side. Pretty simple, straightforward. Now, if we come to the training loop in Burn, generally what you're going to do is use a learner builder to set this up. Technically, there is a GAN example available in the Burn repository, which shows how to do a loop, which is a bit more like the PyTorch loop, and that's going to enable you to do things like multiple optimizers. So that can be important for certain architectures, but for most, the learner builder is great, and it comes with a dashboard, which sadly you don't get with PyTorch by default. So this dashboard is a great terminal UI, shows you your loss, your accuracy if you set it up, your GPU usage, and that's just very useful. Makes it easy to stop early if your model has learned well enough. So we set some of the hyperparameters here. The number of epochs, I set this to 500. That's a little bit high. Most models, depending on the size, are going to learn within 50 epochs, but not all of them do, and sometimes you just want to give it that space. It won't affect anything other than the potential duration. You can still stop early, so it's no issue. Number of workers simply specifies for when we are loading our data set, how many workers, CPU threads we have supporting that process. So I set it to a modest number of 4. The seed can essentially be any number, and we use the seed to shuffle our data here. And that's a great way to make sure that you're not loading in the sequences in the same order for each epoch. That way, the model really learns the patterns really well and doesn't just memorize the patterns necessarily. We use the Atom W config. I found that it works a little bit better than the Atom config, but it's very similar, and it's just one component of your architecture, so it's not always going to make a huge difference. For the batch size, though, I experimented with very high batch sizes, like 256, as well as the lower 4, 2, and even 1. And what I found with 1 was it was for this task of generating motion path keyframes, it was just learning it much more accurately. And that's important. If it's generalizing too much, the paths, they're just not going to make very much sense. So long as you run your burn code on release mode with the release flag, it's going to be lightning fast. So there's not too much of a reason to use a high batch just to speed up the training process, so long as you use that release flag. So anyways, we set up the atom W here with a weight decay. A lot of people set this a little bit higher. I set it a little bit lower. It seemed to have a minor positive effect. So experiment with it. It will essentially penalize a large gradient. So if the model is sort of going off the beaten path a little bit too much, it will receive an extra penalty for that. Then as we continue on, we set up the RNN model, which we'll cover in an upcoming video, which is the actual training model, the code itself. We use our motion data set to load in the text files that contain all of the data, set up the batcher, ultimately pass that into Burn's Dataloader builder, and we come to our learning. And this ties basically to every hyperparameter that you set, but it's largely tied to the task at hand, the data you have, and the batch size. So for certain batch sizes, you might go a little higher. For example, you can see I have this commented here. Depending on your task, high learning rates like this one are just going to be very erratic and not good at all. Other very low learning rates, maybe -6 or 7 or 8, you might notice no training, no learning happens. So you've really got to be patient and experiment with different learning rates and be mindful of the other hyperparameters because they're all sort of interdependent. You can use a scheduler of some kind to basically change the learning rate throughout the training, and this can definitely help with certain tasks and certain training. It's not always necessary. If you find a good learning rate, that's what matters the most. And usually people will use these and work between two learning rates that are both fairly good, but they want to balance between them. And so that's where those come in. Ultimately, we set up the learner builder. I included the GPU metrics, the loss metrics. I didn't include the accuracy on this one, as it just wasn't necessarily going to be that helpful to know if it was getting the exact values. The loss is a little bit more helpful depending on the task. It can show you how close you're getting, generally. And it just all gets brought together right here on build. And it's really that simple. It's really that simple. So there you have it. That's how you set up the data loader and the training loop with Burn. Hope you enjoyed it.